Hi and welcome back to another LeetCode session. Today I thought I'd be using neatcode.io. It has this nice roadmap of the blind 75 or blind 150 question list. And I'm going to go into backtracking problems. And the nice thing about neatcode is you can, you have a link to LeetCode, and you also have a link to a video explanation, including runtime analysis if you want to look things up. So we're going to use this link here to open the problem on LeetCode. And I haven't done this in a while, at least not that it works. So I'm going to try this today again. So this is LeetCode problem 78 about subsets. We're given an integer array nums of unique elements. Return all possible subsets, meaning the power set. The solution must not contain duplicate subsets. Return the solution in any order. All right, and the constraints is, well, we have at least one element in our nums array that we're getting. And the elements have different values, okay. And all numbers in nums are unique, which is good. So yeah, let's just look at this, at those examples real quick. So if we have the number 0, then the power set contains the empty set, the power set of the set of numbers that is 0 contains the empty set and of course the original set. And the empty set is part of any power set. So if we have the numbers 1, 2, 3, that means we have all the different possible subsets. So the first possible subset is to have just 1, just 2, just 3. The second is to have 1 and 2, 2 and 3, and 1 and 3. And the last one is the one that contains 1, 2, 3. And because we're dealing with a power set, the order of the elements in the subset doesn't matter. So 1 and 2 and 1 is the same thing. Right, so, well, how do we approach this? I don't know if you remember this maybe from school or whatever, but to compute the power set, so if you have like an empty set that, well, when you have like 0 elements, right, and if you have no elements in your nums, then the power set will still contain the empty set. If you have 2 elements in your, or 1 element in your power set, then, sorry, in your original set, then the power set will contain the empty set and the set that contains your 1 element. If you have 2 elements in your set, then, well, you have all of the individual elements from the set in your power set, as well as, of course, the entire set and the empty set. And what you can see here is that as we increase the length of our original set, right, nums, that's what I'm talking about, the number of possible combinations of those, what do you say, of those elements from the set just grows exponentially, right? And finally we have 1, 2, 3. So what you can see here, there's a pattern where the length of the power set is, well, if you have n, then that means the length of your power set is going to be, well, 2 to the power of n. Where's my caret? 2 to the power of n. 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 3 of 2 is 4. 2 to the power of 3 is 8, right? Do I have all of them? These are 4. 1, 2, 1, 3, 2, 1, 1, 2, 3. I'm missing the 3 element here. Yeah, is 8. So to compute the power set of nums means, well, we're going to need at least O of n to the power of 2 time to construct each of those subsets, as well as space to store all of them, right? So, oops, wrong way around. So this should be 2 to the power of n. Yes, so that would be my runtime and space analysis. But the big question is now, how do you construct, you know, the sets? And I guess that's something you will just have to remember. But there's also a way of how you can derive it. I mean, if you get this in an interview and you don't remember how to do it, maybe you can remember how to derive it. And basically what you do is you start with the empty set as your seed, right? So if you have subsets, right, you can start with your seed, and the seed is the empty element. So your power set contains only the empty set, which it always does in all cases. Now, what you then do is you just iterate over all of the elements in your set, right, in your list, because it's guaranteed that you have all of these elements in there. All of the elements that are in your nums are going to be in your power set, right? So what you do is you just iterate over them for n in nums, right? And then basically what you do is subsets.append n. Well, what is now the next step? Well, and by the way, just appending them is the same as combining them with the empty set, right? So in the next step, what you need to do is you need to combine all the 1 elements with each other to get all the 2 elements. So if you have 1, 2, 3 in your set so far, you will now put 1, 2, 1, 3, and 2, 1 into your power set. And then you start combining all the elements of length 2. So you get 1, 2, 1, 3, which is the same as 1, 2, 3. And then you combine these two, which is 1, 3, 2, 3, which is the same as 1, 3, 2, which is the same as 1, 1, 2, 3. So you build that set up iteratively by combining all the elements that you created in the previous iteration with each other. And that generates all of the subsets and subsequently with increasing length. Now, if you want to put this into code, right, you probably need like a temporary thing into which you put the elements of your current length. So in the beginning, you want something empty, and then you would probably just add the new sets that you computed to your subsets. So we know we can put subsets dot extend, and we're just going to, whatever we put into TMP, we're going to add that to our power set. To our, the power set is the subsets thing. Like so. And so, yeah, so how do we do this now? Well, we can just iterate over all of the sets that we currently have in our power set and combine them with n. And so for subset in power set, TMP append subset plus n. Now what you see here is kind of a transposed insertion compared to this. So what we do up here is we start with the empty set, then we combine it with 1. So we will get 1 in the first iteration. Start with the empty set, and n is 1, right? So we combine 1 with the empty set, and it's just going to be 1. Now in the next step, we're going to take 1 becomes 2. And we're going to combine 1 with the empty set, which gives us 2. But we're also going to combine 2 with the set that contains the 1. Right? So these are what happens in these iterations. Now next, n becomes 3. So we're combining 3 with this one. This is already in the power set, so that becomes 3. Next, we're combining 3 with the 1, right? So that becomes 1 and 3. Next step, we combine it with the 2. So we have 2 and 3. And now we combine it with 1, 2, and 3. And so now we're pretty much done. And if you look at this, we've got all of our sets in here now. All of them. And even because we add them at the end here of the subset, we even get this exact same order that we have here. And we have no duplicates. So yeah, so that's kind of the trick of how to do that, or how to organize it efficiently. There are other solutions that are much more complicated, but this one is the easiest one. Iterate over the elements in your set or in your nums, and combine them with everything that you've already computed with your power set. That's the idea. So if I run this now, It passes the tests. If I submit it, it should also pass. Yeah, so there you go. So that's LeetCode 78. It's a medium problem, how to compute the power set.